One great example of something that works with exponential growth is compound interest. And this has to do with finances. So if you've taken personal finance, hopefully you've heard about compound interest. If you don't know what interest is, it's a way to make money from your money. When you put money in a bank, you're going to gain interest on that, and that's a good thing. When you take a loan and you owe money, a bank's going to charge you interest on your loan, and that's a way for them to make money off your loan. So in that case, it's a bad thing. So here's a chart that I'm going to use to kind of walk through how earning interest works. So let's say we take $1,000 and put it into the bank or some account, and they tell us that they're going to give us 10% interest. So for letting them have our money, we're going to make 10% of that back each year. Okay? So we put $1,000 in. At the end of that year, they're going to give us 10% of that amount. So 10% of that 1,000 is $100. So they put $100 into our account. So just by letting that money sit there, we've earned $100. Okay? The next year, same deal. But now we have $1,100 in our account. At the end of that year, they're going to give us 10% of that new amount. So 10% of that $1,100 is going to be another $110. So we add $110 to the amount that we have. Year after that, now we have $1,210 in there. 10% of that is going to give us an extra $121. Okay? And so you see as the account grows, the amount that it gets to grow by increases every year. So at first we only got to grow by $10, then the next year it was a little more than 12, and then it looks like a little bit more than 13. But by the change from 9 to 10 years, that's over $200 that our money gained in interest. Okay, so it grows exponentially because as it gets larger and larger, it's able to grow faster and faster. So compound interest is a fantastic thing, and I hope you pay attention to this because it's especially great if you can take advantage of this when you're young. Because imagine this letting go for 40 more years. You know, if you put money into something when you're 20, let it sit there and just grow and gain that compound interest until you're close to retiring, you're going to have a lot more money than somebody who didn't start this saving until they're 40. Okay. To calculate this compound interest, we're going to use this formula where A is the amount. Okay, so A is the amount or the value of our account. P is the principal, so that's the initial amount that you put in. So in the previous example, your principal was $1,000. And then we're going to multiply that by 1 plus R over N. R is the rate that we're getting. So on the last example, that was 10%. N is going to be the number of times that gets compounded per year. So again, the previous slide, it was compounded once per year. Maybe it's going to get compounded every month, maybe once every quarter, maybe every day. Eventually we'll even talk about what if it's compounded continuously every single moment. And then that's to the NT power. So what's really happening here is we take our principal, we're multiplying it by 1 point something. We take the rate that we're getting divided by the number of times per year. So if it's 10% once per year, that's going to be 0.1 as the decimal. So we'd be multiplying by 1.1. So that would give us the extra 10%. But then that's to the power of however many times that compounds. So let's look at this first example. We're taking $5,000. We put it into an account that pays 4% interest per year. So that's our rate, and that percent as a decimal is 0.04. Okay, how much will that account be worth after 5 years? First, if we compound that interest annually. So in our first case, N is 1. We're compounding it once per year. So all we really have to do is just take and plug all these in. P equals, not P. A is our principal of 5,000 times 1 plus r is 0.04 over n, in this case is 1, and that's going to be the only piece that changes in the next examples. To the n is 1 times 5 years. And with your calculator, if you have one of the nicer scientific ones, you can plug that all in together at once. Maybe you have to go step by step following the order of operations. But crunch that out, and it looks like we get roughly $6,083.26. Okay. So that's a good chunk of change. That's $1,000 that we gained in just 5 years. So then if we want to find out how much we would have if it was compounded every month, we would still have the same formula, but it would be 0.04 divided by 12 to the 12 times 5. So what's kind of happening there is, like in the first one, the 0.04 over 1 is going to give us 1.04. If you do 5,000 times 1.04, that's going to add 4% of that. But then we do that over 5 years. We do that 5 times, so we multiply 5,000 by 1.04 times 1.04 times 1.04 times 1.04 times 1.04, because it gets compounded 5 times over those 5 years at 4%, and that gives us this total. In this case, that annual 4% gets divided among 12 compoundings, but then that happens 12 times over those 5 years. So this is going to give us 1 point something, and we multiply it by that 1 point something 60 times, because that compounding is going to be, it's a smaller percent, but more times over those 5 years. So plug that in, crunch it out, and we get $6,104.98. So maybe you notice that compounding a little bit more often earned us a little more, over $20. So then do the compounding for every day, where your n is going to be 365. Just use 365. Assume it's not a leap year. And so there is how we would calculate compound interest. It's a good thing. You should remind your personal finance teachers that you want to learn more about it, because some people consider compound interest to be the eighth wonder of the world.